Have you ever gazed up at the night sky and wondered, are we alone? It's a question that has captivated humanity for centuries. We've sent probes to Mars, gazed at distant exoplanets, and dreamed of the day we might find life beyond Earth. But what if our quest to find life inadvertently destroys it? This is the central dilemma of interstellar contamination, a topic that sounds like science fiction but is a very real concern for scientists today. Let's break it down. There are two main types of contamination we need to worry about. The first is forward contamination. This is when we, humans, accidentally carry earthly microbes to other celestial bodies, like Mars or the moons of Jupiter and Saturn, such as Europa or Enceladus. Imagine this. We spend billions of dollars and decades of research to send a rover to Mars. It drills into the soil, searching for signs of ancient Martian life. But what if the life it finds is just a hardy bacterium that hitched a ride from the clean room back on Earth? That would be a scientific catastrophe. It would be like trying to find a single unique grain of sand on a beach. But first, you accidentally spill a whole bucket of your own sand right on top of it. The original signal, if it was ever there, is lost forever in the noise we created. This isn't just a theoretical problem. Microbes are incredibly resilient. They can survive extreme cold, radiation, and the vacuum of space. The process of sterilizing our spacecraft is incredibly rigorous, involving baking components at high temperatures and using powerful chemicals, but it's nearly impossible to guarantee 100% sterility. A single surviving spore could, in theory, find a new home on another world. If that world has the right conditions, like subsurface water on Mars or the hidden oceans of Europa, our tiny terrestrial stowaway could potentially thrive and outcompete any native life that might exist. We could become the invasive species on a galactic scale, wiping out an alien ecosystem before we even knew it was there. The ethical implications are staggering. Do we have the right to risk destroying a potential biosphere, no matter how simple, for the sake of our own curiosity? This question is at the heart of an international treaty called the Outer Space Treaty. It states that all exploration must be conducted so as to avoid the harmful contamination of celestial bodies. Organizations like COSPER, the Committee on Space Research, set specific guidelines for planetary protection, categorizing missions based on their destination and the type of science they'll perform. For missions to potentially habitable worlds like Mars, the standards are incredibly strict. But here's where it gets even more complicated. What about human missions? It's one thing to try and sterilize a robot. It's another thing entirely to sterilize a human being. We are walking, talking ecosystems, home to trillions of microbes that are essential for our survival. If we send astronauts to Mars, they will inevitably bring their microbial companions with them. Every breath they exhale, every flake of skin they shed, will release Earth life into the Martian environment. This makes the risk of forward contamination not just a possibility, but a certainty. So does this mean we should never send humans to Mars? Some argue yes, that we should explore these worlds with robots only, to preserve them in their pristine state. They argue from a principle of cosmic precaution, that we shouldn't interfere with a world that isn't ours, especially when the consequences are irreversible. Imagine a universe where life is incredibly rare. If we carelessly destroy one of the few other places it exists, we've committed a crime of cosmic proportions. Others argue that human exploration is an essential part of our nature and our destiny. They believe the potential rewards, the knowledge, the inspiration, and the potential for a second home for humanity outweigh the risks. They propose creating special regions on Mars, areas thought most likely to harbor life, that would be off-limits to human explorers, at least initially. Astronauts would be confined to other, less biologically sensitive zones. But can we really contain ourselves? History on Earth is filled with examples of quarantine lines being crossed. It seems almost inevitable that our presence would eventually spread across the entire planet. Now let's flip the coin and talk about the other side. Back contamination. This is the scenario that has fueled countless sci-fi horror movies. What if we bring something back from another world? We drill for ice samples on Europa, seal them in a canister, and bring them back to Earth. Inside that ice is an alien microorganism. If that organism escapes our containment facilities, what happens next? The chances of an alien microbe being harmful to Earth's ecosystem or to us are probably very low. A life form that evolved in a completely different environment would likely not have the biological tools to infect or thrive on Earth. It would be like a saltwater fish trying to live in a freshwater lake. It's just not equipped for it. But low risk isn't no risk. The potential consequences, however unlikely, could be devastating. An alien microbe could be a superpathogen that our immune systems have no defense against, or it could disrupt our ecosystem in unpredictable ways. This is why any sample return mission from a potentially habitable world will involve the most extreme quarantine procedures imaginable. The Martian samples that NASA's Perseverance rover is currently collecting will, if they are brought back, be treated as the most dangerous materials on the planet until proven otherwise. They will be opened and studied in a specialized biosafety Level 4 facility, designed to contain the deadliest earthly pathogens. The debate around sample return highlights a fundamental tension in science. We are driven by a desire to know, to touch, to analyze. Getting a sample in a lab on Earth would allow us to perform experiments that are impossible for a rover to do on Mars. We could learn so much more. But that desire comes with a profound responsibility to protect our own home. Is the knowledge we might gain worth the risk, however small, to our entire planet? As we stand on the cusp of a new golden age of space exploration, with private companies and multiple nations all aiming for the Moon, Mars, and beyond, these ethical questions are more urgent than ever. Who gets to decide what level of risk is acceptable? Is it the space agencies, the governments that fund them, or should it be a global conversation? And as we push further into the cosmos, what is our ultimate responsibility? Are we just explorers, or are we caretakers? Some thinkers, like the late Carl Sagan, advocated for a kind of cosmic ethic, a sense of responsibility not just to humanity, but to the cosmos itself. He saw the universe as a vast, magnificent place, and believed we should tread lightly and with humility. The search for life is also a search for what it means to be human. It forces us to confront our own values, our limitations, and our place in the universe. Perhaps the greatest discovery we'll make out there isn't alien life, but a deeper understanding of our own responsibilities. The choices we make in the next few decades will shape the future of exploration for centuries to come. Will we be remembered as the reckless contaminants who spread our biological signature carelessly across the stars? Or will we be remembered as the thoughtful pioneers who explored with wisdom, respect, and a profound sense of awe for the universe we are so lucky to be a part of? The future is unwritten and the stars are waiting. What do you think we should do? Let me know your thoughts in the comments below. Thanks for watching, and don't forget to subscribe for more journeys into the frontiers of science and ethics.